Alright, in this example, I would like to go over how to factor out the greatest common factor, denoted by GCF. Now, think of factoring as undistributing. So if you distribute something, that means you take that something and you multiply it by each term inside a parentheses or inside a parentheses of an expression. Well, factoring is kind of like you're going backward. You go from having an expression to having something on the outside and then multiply a parentheses, and then inside parentheses is just the leftover of the original expression. So think of factoring as undistributing. Now in order to do that, we have to break each term down to its prime number multiplicative factors, as you have seen at the beginning of this video. Okay, so let's go from left to right and break each term down into its respective prime number multiplicative factors, or should I say prime factors. Okay, so for 30, w to the 6, so you got 30 times w to the 6. Well, let's see, usually people think of 30 as 6 times 5. Okay, so we write it down. And w to the 6 is just w multiplying itself 6 times. 1, 2, 3, 4, 5, 6. But 5 is a prime number because the only multiplicative factors of positive 5 are positive 1 and itself. So this is a prime number. Each of the w is also a prime factor. But not number 6. Number 6 is a composite number. Okay, it is a composite number because we can rewrite number 6 into the product of two smaller numbers. Well, in this case, they are positive 2 and positive 3. And I bring down everything. Okay, well, let's check. 2 times 3, that's 6, times 5, that's 30. 2, 3, and 5 are all prime numbers. And each of the w, as mentioned, are also prime factors. So each of these factors are prime of this term, 30 w's raised to the 6. Now let's do the same procedure for each of the other one. So for 25, w to the 5th, well, 25 is 5 times 5. And we know each of these 5 numbers is prime number factors of 25, so we're good. W to the 5th means w multiplying itself 5 times. Okay, so all of these are prime factors of this term. Let's try negative 10w to the 4th. Well, the negative side, we can think of it as negative 1. Well, I mean, it is technically negative 1. Now, with the negative side right here, what about a 10? Well, a 10 can be written into the prime number 2 multiplying the prime number 5. Because 10 is a composite number, so that's why we have two smaller numbers, 2 and 5, which are prime numbers that multiply together to give us back the 10. W to the 4th, well, same fashion as above. Means it multiplying itself 4 times. Now the last one, negative 20 w squared. Well, let's say the negative side is the negative 1. 20, well, people like to think of 20 as 2 times 10. And then w squared is w times w. Negative 1 is a prime number, 2 is a prime number. W and w are also prime number factors, but not 10. 10 is a composite number as mentioned before. So bring down the negative 1, bring down the 2, break the 10 down to another positive 2, and another positive 5. Okay, negative 1 is a prime number. 2, 2, and 5 are also prime numbers. So all of these are prime number factors of negative 20 squared. Now this is when we collect all of the numbers, or all of the factors that we have in common from each of these lists of factors. Okay, so for the first list of factors of the first term, and then we'll just compare it down to the other list. Okay, so in the first list we have positive 2, but we don't have it in the second list. We have it in the third, and we have it in the fourth. So because one of these 4 lists of factors is missing the positive 2, positive 2 is not part of the greatest common factor. So we have to disregard it. What about positive 3? Well, it's in the first list, but not the second. So you see immediately right there, one of the 4 lists of factors is missing the positive 3, so it is also not part of the GCF. What about positive 5? Well, we have positive 5 right here, another one in the second list, another one in the third, and another one in the fourth. So hey, all 4 lists have the factor positive 5. So we'll circle that to note it. Now, what about the first W? We have one W right here, another one in the second, another one in the third list, another one in the fourth list. That's another one. That's another part of the GCF. The next W, in the first list, in the second list, in the third, and in the fourth. Oops, I don't know why I circled this. My bad. What about the next W? Well, we have this W in the first list, in the second, in the third, but not in the fourth. Because in the fourth we don't have anything else. So this is not part of a GCF. The next one, in the first, in the second, in the third, but not in the fourth. Because again, the fourth list of factor doesn't have anything else. So this one is out. Same thing for this one. This W is in here. The third leftover W is in here. It is in here, but it's not in the third list and not in the fourth list. And of course, the same thing for this. It's in the first, but not the second, third, or fourth. So the one in the circle are all of the common terms. All of the common factors that we have to bring to the outside. So we got 5 times W times W, 5 times W times W, same thing and same thing. So that means we bring it outside. 5 times W times W. Multiply something inside the parentheses. Well, with this inside, it's just the leftover of what we have up here in all 4 lists of factors of each of these terms. For the first term, the leftover is going to be 2 times 3. And then W multiplying itself 4 times. In the second list, we got 5, and then W multiplying itself 3 times. So plus 5, then W 3 times. In the third list, we got negative 1 times 2 times W times W. So hopefully I can squeeze it somewhere in here. Plus negative 1 times 2 times W times W. Okay, and for the fourth one, I'm going to write it down here. Where you can see it there. For the leftover, the fourth terms, we got negative 1 times 2 times 2. So that plus negative 1 times 2 times 2. Left over the first term, left over the second, left over the fourth. Left over the third, and left over the fourth. Well, let's put everything together. 5 times W is 5W squared 2 times 3, that's 6. And then multiplying w 4 times, so that's 6 times w to the 4th plus 5 times w 3 times, so 5w to the 3rd. And then let's see, negative 1 times 2, that's negative 2 times w, so that plus negative 2w squared, so that minus 2w squared. And then plus, let's see, negative 1 times positive 2 is negative 2. Negative 2 times positive 2 is negative 4. So plus negative 4, that means minus 4. And this is the factor form of this expression in terms of factoring out the greatest common factor. Okay, so overall, make sure you always break each term down to all of its respective prime number multiplicative factors in order to be able to collect all of the, well, I say all of the parts, or more like all of the factors of the greatest common factors of this expression. Okay, so that's how you factoring out the greatest common factor of any given polynomial expression. Now, as you continue to practice, you would realize that every time when your coefficients have the identical variables, in this case they are w, but each of these variable is raised to different exponential power, you would notice that when you factor out the greatest common factor, you would actually factor out the variable with the lowest exponential power. So in this case, my variables are again the w, but the lowest exponential power of the variable w is the power 2. So that means I would factor out that variable w with the lowest exponential power 2, right there. Okay, and you would notice, you know, like I said, as you continue to practice this concept. Okay, all right, you guys, thank you for watching. See you guys next time.